Welcome to the second of two logic videos. I'm going to continue on with the question from the very first of the logic video, so it might be good to take a look at that before. Introduce us to some new symbols. We have the cap, the cup, and a symbol that we've seen before in probability, the complement, or the sort of straight line on top of a word or a symbol. So let's start with the cap. This cap here, it looks like an upside down U, and it refers to the intersection. So what we're looking for here is elements or members that are for part of the intersection between set C and set S, which means what members are in both set C and set S. So if we're looking at our Venn diagram, that makes it very easy. The Venn diagram organizes that. But basically, if we didn't have the Venn diagram, we would be saying, okay, set 9 is part of the intersection. It's part of the overlap between set C and set S, and also 5. So for the intersection between set C and set S, we would say 9 is an element and 5 is an element. For this cup, so this cap and cup, this looks like, it looks identical to a regular shaped U, but it refers to union. So it's the marriage between set S and set E. So it has to be things that are in either of set S or E. So if intersection refers to, A and B, union is referring to A or B, or in this case, S or E. So here we have to make a union or sort of combine the two sets. So these are all the things that are within set S and set E. And if you notice, the only thing that's not is 3. So we would have 1, 2, not 3, 4, we would only show that once, 5, 6, 7, 8, and 9. So all the elements that are the union of set S and E. This guy's asking for the complement, so what are the members of the set that are not in set E? So all the things that are in the universal set that are not in E, so we want to sort of cover up E and say what are the elements that are not in E, or what are elements, integers from 1 to 9 that are not a part of this set. So we'll get 1, 3, 5, 7, and 9 to be all the integers that are not in E. So, order of operations, bedmiss, do your brackets first. That's all that this is. It's starting to look kind of crazy, but let's just sort of take it one step at a time. Let's do this bracket. Let's find the union between set C and set S. And then we'll find the intersection between that and E. So the union between set C and set S. So what are all the things that are either in C or S? Hey, look, it's all of them. So all of them intersects with E. Well, now we only have, happens to also be the equal set to E. So E intersects with C, and then we're going to have the union with S. So look for the intersection between E and C. We see it right here. So 2, 6, and 8. Now we're going to have a union with S. So all the things that are in S, even though 4 was not a part of this one, it is a part of S. And the 2, the 6, and the 8. So again, we almost kind of have the same ideas up here. So we're taking that intersection between E and C and making a union with all the other things that are within set S. And the last one, what is not in C and marry it to or form the union with the things that are not in S. So look at the things that are not in C. So 7, 1, and 4. Those are within the set, within the universal set, but are not part of C. And let's form a union between that and the things that are not in S. So now we're going to be putting those guys together. So we'll put them together. So everything except for 9 and 5. Have fun.